Welcome to Lesson 3, Basic Terminologies. Understanding key terms is crucial for effectively managing and interpreting a construction project schedule. Below is an explanation of essential scheduling terminology, including milestones, tasks, dependencies, critical path, float, Gantt charts, and other important concepts. Milestones. Milestones are significant points or events in a project schedule that represent the completion of a major phase, deliverable, or activity. They are typically zero-duration events but serve as markers to indicate progress. Purpose. Milestones help project managers track and monitor the project's progress and ensure that the project stays on schedule. They often coincide with project approvals, stakeholder reviews, or critical deadlines. For example, in a construction project, milestones might include the completion of the foundation, the framing of the building, or the approval of design plans. Tasks or activities. Tasks, also called activities, are the individual units of work that need to be completed to achieve project objectives. Tasks are the building blocks of the project schedule, each with a defined duration, resources, and dependencies. Purpose. Tasks break the project down into manageable units of work, allowing the project team to focus on completing smaller, more specific objectives that contribute to the larger project goals. For example, tasks in construction might include activities like excavating the site, laying concrete, installing electrical systems, or painting. Dependencies. Dependencies define the logical relationship between tasks, determining the order in which tasks must be completed. There are four main types of dependencies. Finish to start. A task cannot start until a preceding task finishes. Start to start. A task cannot start until a preceding task starts. Finish to finish. A task cannot finish until a preceding task finishes. Start to finish. A task cannot finish until a preceding task starts, and this rarely is used or happens in normal project life. Purpose. Dependencies establish the sequence of activities and ensure that tasks are completed in the correct order to avoid delays or conflicts in the schedule. For example, in construction, the dependency might be that the framing of a building, task A, must be completed before the roof can be installed, task B. This is a finish to start activity. Critical path. The critical path is the longest sequence of dependent tasks that must be completed on time for the entire project to finish by its deadline. Any delay in a task on the critical path directly affects the project's completion date. Purpose. Identifying the critical path allows project managers to focus on the tasks that have the most impact on the project schedule. It helps in prioritizing resources and efforts to ensure that the project stays on time. For example, in a construction project, the critical path might include tasks like site preparation, foundation pouring, and framing, all of which need to be completed sequentially without delay. Float or slack. Float, also known as slack, is the amount of time a task can be delayed without affecting the project's overall completion date or other dependent tasks. Total float, the amount of time a task can be delayed without delaying the project completion date. Free float, the amount of time a task can be delayed without delaying the start of the next dependent task. Purpose. Float provides flexibility in managing the schedule by indicating which tasks have room for adjustment and which are time critical, that is, tasks on the critical path. For example, if a non-critical task like landscaping has a float of 5 days, it means it can be delayed by up to 5 days without impacting the overall project timeline. Gantt chart. A Gantt chart is a visual representation of the project schedule, typically displayed as a bar chart. It shows tasks as horizontal bars along a timeline, indicating their start and finish dates, durations, and any dependencies between them. Purpose. Gantt charts are commonly used to visually track progress, identify overlapping tasks, and communicate the project schedule to stakeholders in an easily understandable format. For example, in a Gantt chart for a construction project, the timeline might show tasks such as excavation, foundation, and roofing, each represented as a bar with varying lengths according to the task duration. The chart also shows how tasks are sequenced. Work breakdown structure. A WBS is a hierarchical breakdown of the project scope into smaller, manageable components, tasks, and activities. It organizes the project work into logical groupings, making it easier to assign responsibilities, estimate costs, and schedule work. Purpose. WBS provides clarity and structure to the project by dividing it into more manageable sections. It helps in assigning tasks to specific teams and creating a more detailed project schedule. For example, for a building project, a WBS might break the project into major components like site preparation, foundation, structure, and finishing. Each of these will be further broken down into smaller tasks. Baseline schedule. A baseline schedule is the original approved project schedule which serves as a reference point for tracking progress throughout the project. Any deviations from the baseline indicate schedule delays or adjustments. Purpose. The baseline schedule is essential for measuring project performance and determining if tasks are being completed as planned. It helps in identifying delays and taking corrective actions. For example, the baseline schedule might indicate that the foundation should be completed by a certain date. If it is delayed, the project manager can compare actual performance against the baseline to determine how the delay impacts the overall project timeline. Lead and lag. Lead. The amount of time a task can start ahead of its predecessor. For example, a dependent task might start earlier than planned if its predecessor doesn't need to be fully completed. Lag. The delay between the finish of one task and the start of another. Lag time is added to allow for buffer time between tasks. Purpose. Lead and lag times are used to fine-tune the schedule and adjust the flow of activities. They help in managing tasks that can overlap, that is lead, or require some waiting time, that is lag. For example, if the painting of walls can start 2 days before the installation of doors is completed, that 2-day overlap is a lead. If the installation of flooring must wait 3 days after the concrete is poured to cure, that 3-day wait time is a lag. Resource allocation. Resource allocation involves assigning the necessary personnel, equipment, and materials to specific tasks in the project schedule. Purpose. Proper resource allocation ensures that the right resources are available at the right time, preventing delays or resource conflicts. For example, allocating a crane to the foundation pouring task to ensure the work can proceed without delay is an example of resource allocation. In conclusion, these basic scheduling terms, milestone, tasks, dependencies, critical path, float, Gantt chart, and others, form the foundation of effective project scheduling in construction. Mastering these concepts is crucial for successful project management and ensuring that the project is delivered on time, within budget, and to the desired quality standards.